A little bit about me and what we do. API Metrics, we're an API monitoring company. We are not a testing company. We've heard a lot about testing over the last hour and a half or so. And some of the questions that came up during those sessions on the subject of what the difference between testing and monitoring is, I hopefully will answer a little. We're about validating that what you think worked the day you shipped it carries on working through the life cycle of the product. And we've built a reputation as a company over the last 6 years, particularly in banking, where we do a lot of hard to monitor API stacks, particularly with very complex security, a lot of security and compliance and risk associated with it. And we have been monitoring UK open banking now across all of the banking providers for the last 4 to 5 years. And we do it with synthetic API calls. And what I'm going to share are some of the lessons we've learned and some of the insights we've derived from doing this that we think are best practices for anybody working with APIs in any sector. So we've done about 30 million API calls, and we've done them across the 3 buckets of banks in the UK. And we break these down into the CMA9, which is the Competition and Markets Authority 9 top banks in the UK. So they're the biggest old high street banks you'd have heard of. Some of them are pan-European, like Santander. Others are Barclays, NatWest Group, HSBC Group. Big names, huge IT departments, massive technical debt. The next group are, and they're the blue line. The next group I've got there, which is the red, the orangey line at the top, they're what we call the neobanks. These are the banks that have appeared in the last few years. They have built stacks from scratch. They have entered the market, often venture funded, but they built everything from the ground up completely new. Very API first, very API forward. And the final group are what we call the traditional banks. These are the smaller UK banks. They have the problem of technical debt, but they don't have the engineering resources. And we score all APIs on the standardized quality scale we invented from essentially 0 to 10. And the first thing we noticed when we looked at the last 12 months was the dotted line is where is an average of all of the top IT services you've heard of, Microsoft Graph, Google Workspaces, DocuSign, Box, Dropbox, and so on. And they scored just under 9. 9 is a very good score. It means that their APIs are consistent, they're high quality, they work well. What you'll notice is the only banks that actually achieve something like that are the neobanks. The blue line are the CMA9, and the CMA9 have been forced to throw enormous amounts of resources at this problem. And that's to overcome their technical debt. In some cases, with IT systems that they're calling via APIs that are older than me. We actually know there are some banking databases in there that date back to the early 60s from the acquisition of a bank that was very tech forward, but they haven't done anything to their databases. And they're running on some ancient IBM mainframe sitting in I have no idea actually, it's just sitting somewhere. So the gray line though, it was really surprising to us just how much worse quality the actual traditional banks were. And we wanted to dive a little bit more into what was making them lower quality and what lessons they could learn from others about making things work better for them. So the first one, when I grew up, I thought quicksand would be a much bigger problem for me in my adult life than it turned out to be. I watched a lot of television shows where somebody was always getting sucked into a quicksand thing. Turns out not a thing. But if you are an API first company and you do not offer any kind of sandbox, you are letting down your developer environment. What we've seen in UK banking is they were mandated to offer sandboxes for everyone. And a sandbox is a very good idea. It allows people to test how your APIs work in an environment where they're not going to break anything. They might not have to worry about the same security, but what we saw happen was they built sandboxes that bore no resemblance to their production environments. They have very different security. They have very different, in some cases, data schemas. They don't even represent the final solution. So people built applications based on a sandbox that when they tried to switch into production didn't work at all. And our view is you need to have sandboxes that look like your developer solution. There are lots of ways of doing that, but it's critical for anybody who's building a solution to have something they can work against. And ideally, it should be a stubbed off version of your own developer environment and not something you built completely separately that will never ever align with the development environment you're going to launch with. The other thing we've noticed, and we've heard this from lots of banks around the world and other companies, is they don't actually pay much love and attention to their sandboxes. So while they worry about whether their production APIs are up, we've seen sandboxes down for weeks at a time because they just don't bother. And that, again, it really limits the ability of third parties to use the APIs that you provide. So pay attention to your sandboxes. They are the gateway to your APIs. Second lesson we learned, documentation. Do not document in PDFs, please. Do not document in PDFs where you have really complicated long-form tokens you have to cut and paste into a query, because that doesn't work. Have somebody who hasn't ever worked on your API check the documentation is true. Oh, time and time again, we saw onboarding the 40 or so British banks that we've been working with, nobody had ever validated if the documentation was correct. Of the 40 banks we onboarded, we got through about a dozen in a day and a half, just all the way through. The next 12 took about a week because we had to ask questions. And bear in mind, these are government mandated APIs that are meant to be completely the same. The last group, some of them took up to 6 weeks, and there are 4 that we have never onboarded. And in theory, this is all the same APIs using the same security with the same protocols. Everything should be exactly the same. And yet, even though there are very few companies that have got every bank onboarded, there are some we still couldn't do. And even they couldn't figure out what they'd done wrong in their stack. So it's very important to keep your documentation up to date. Use tools that allow people to test the calls and don't put things into static files. A third lesson was, and I think this is a very important thing that's been emerging today as a theme, and Mark O'Neill touched upon it in his keynote. Don't ignore the API supply chain. And what I mean by that is, I used to call this slide there and back again, but I've come around to API supply chains. Your API and the APIs you use do not exist in a vacuum. They are part of a whole chain of events that a third party using your API will be taking part in. If you focus on your API stack or what happens behind your firewall, you are ignoring the cloud infrastructure that they are on, the internet connectivity between wherever their application is and you, your own CDN system, whatever load balancers you're using, whether you have services running on different authentication servers, so if you're using an Okta or Ping identity or something else, all of these technologies have to work in concert. And you can't just rely, because they're not necessarily all in your stack, that your New Relic setup or your Dynatrace setup is going to tell you how they're working. So it's very important to look from the outside in at how your systems are working from the point of view of the customers who will be calling them. And more frequently than you could imagine, I'll come on to some actual stats on this, we found massive differences in latency and performance based on different cloud data centers that people used. DNS is still a factor that impacts everyday performance of APIs. If we've found companies assumed because they'd bought Akamai, all of their DNS problems would go away, or they'd use CloudFront from AWS. Turned out they didn't realize they had to configure it for their API solution. So even though they had got a CDN that in theory removed all of the problems with DNS, it didn't actually work for the domain api.them.com. And it was basically, as far as the internet was concerned and cloud data centers, it wasn't there at all. So this is DNS lookup time. So these are milliseconds. Yeah, these are not high times. 40 milliseconds is pretty quick, but note the difference between making a call from an IBM data center and making one from Azure. It's nearly twice as long. And when you start to add some of these things up into different transactions, and then you look at the technical debt on the back end, you can start to see some huge differences in latencies appearing between companies doing exactly the same thing with exactly the same APIs. Bear in mind, these APIs are functionally identical. They are mandated by the British government. It's why it's such a fascinating data set to me. These are APIs from large companies doing exactly the same thing. And yet, there is nearly a nearly half-second difference between the best and the worst. Half a second is quite a lot of time in an API transaction. If you've got chains of APIs and you've got an extra half second per each one, you could be looking at applications spending minutes doing things that other applications from other providers are not. But it's not always visible to you where these things happen. We've had customers get into quite evangelical fights with their own engineering groups over external monitoring saying something takes a second and a half per transaction. Their internal logs assure them it's only half a second. Obviously, we're lying liars who are trying to make them look bad, but when they actually do it themselves, they find, yes, there's a second being lost because of DNS, because of poor SSL handshake, because of things that they were not aware of happening between one specific application in the cloud and a data center they just didn't understand worked differently to how they thought it did. The other thing we've noticed is you can't rely on all the data centers being the same. There's a general feeling that, well, everything from AWS runs the same everywhere. No, it doesn't. Azure does not run the same everywhere. Google does not run the same everywhere. You need to have a think about what you are calling and potentially see what wins you could have just by moving things. We've seen as much as a 2-second difference by moving something from a data center in Frankfurt to one in Paris, depending on the application that you're using. That's 2 seconds per call. So, following on from that, everybody lies. Everybody lies everywhere, and especially HTTP codes. My friend Gregory House really does pull this out for medical things, but it's the same for APIs. I don't like to make fun of HTTP 200, okay, but it turns out a lot of times HTTP 200 is not okay. One of the things we started to see was as much as 1% of the calls from one of our customers were returning 200s, which they thought was great, and their gateway said, yes, 200, fantastic. But it didn't return actually any content in the 200. It returned what looked like it was correctly formed JSON, it just didn't have the bit in it that you needed to make any other calls with, which in this case was a list of the accounts associated with that user. But as far as their internal systems and their internal monitoring was concerned, this was a successful API call. Flipping that around, HTTP 400s, there's a terrible trend in operations teams of assuming a 400 code, which is the warning code, which is a terminology I really wish we get away from, is somebody else's problem. It's a client error, whatever that really means. But sometimes, if you get a 400, it might be the correct response to the platform. If a OAuth token has expired, yes, but 400 is exactly what you should get. But if you've got an API, for example, we've seen with no security where you get a 400 back, there's no reason to have a client error. That is a platform failure on the back end. And we've seen these ignored because everyone assumes that it's somebody else's problem. So it's vitally important to do checks on the services and do validation checks on what you expect to come back and whether it's the correct thing, and have some kind of escalation policy internally for how you work with them. We in-house use PagerDuty, but there are other tools you can do, just to make sure that when we see a cascade of certain types of thing happen, we investigate it rather than just assuming it'll sort itself out. The other thing that we've seen, particularly in API security, because we do a lot of secure APIs, is you need to do some validation on whether the security is working at all. And there's lots of API security vendors, and we partner with a lot of them. They check that no one's attacking you, that no one's trying to break into your house. But imagine if you've got the best alarm system in the world. You can guarantee nobody will get in without setting off an alarm. It doesn't help if you left the window open or the door open with your car keys next to the door. At some point, it helps to check that you've locked the door. We have seen, and I will not name names, we have seen companies who turned off the security at 2:45 in the morning to fix something in an emergency and forget to turn it back on. And then wonder why suddenly people couldn't get access tokens anymore. But they weren't doing any functional checks on the security structure to actually verify that the token engine was working correctly. So these are little things that, because it's quite hard to do in production, people forget to do, or they just assume something else has it covered. So don't assume, verify, or trust but verify. The other type of scenario we've seen with this is if you are assuming something works, and it has always worked, and this is a classic for everybody in IT, don't assume it will continue to work. The number of times we've seen something that was working for weeks, hasn't been touched, for no readily apparent reason suddenly start failing, is enormous. And that's just, you have to verify that these services are working and not just take it on faith. My last lesson in this is be kind to frogs. And there's the old thing of you put a frog in warm water and then you start heating it up and eventually the frog is boiled alive because it doesn't notice it's got hot. A lot of systems out there still rely on things like rolling averages. Do not use averages. Do not use averages for anything. P90 and P99 values, so the worst 10%, the worst 1%, they are better, but they're still not ideal. And they're not ideal because of graphs like this. So this took place over the course of about 6 weeks. And they used their APM stack used a rolling average system, and the increase in the latency of this API was almost exactly just under the threshold for tracking an alert in their system. I think we got up to, before we came in and said, by the way, this call is taking 16 seconds now, they hadn't noticed. It's very easy in DevOps systems to set thresholds that you think are sensible, and your systems will find a way of making that hurt for you later. We had one customer where every Wednesday morning they'd wake up to a pile of tickets from customers complaining about performance. They'd go and check everything. Everything was green, nothing was down. They didn't understand it. It turned out there was a batch job that ran Tuesday afternoons that took the latency, which basically for 3 or 4 hours took the system down and made it unresponsive. But the actual average latency for the day across all transactions stayed under the threshold for making an alert. But they had a 2-hour window where people tried to do things where they just didn't notice. So you just have to be a little bit careful that averages and rolling averages can cause problems. We've also seen problems with SSL handshakes happening from only one data center, but if it's where a lot of your traffic comes from, it will be problematic. But if your monitoring tool, your synthetic monitoring tool only calls from AWS data centers, and the problem your customer is having is from Azure, you will completely miss it. So again, you need to monitor from where your customers are, not from where it's convenient, because Postman's monitors run on AWS. So, in conclusion, in general terms, open banking is done very well. It was a very hard problem that the UK decided to jump into before everybody else. They have got access to all of the major banks in a standardized way using, we work in multiple jurisdictions now, but the UK's cracked the problem of certifying how people access bank accounts and making it very transparent. But it's very interesting that the new banks who have built their infrastructure from scratch perform so much better than the traditional ones. Technical debt really impacts performance. And when you're integrating to a solution where you worry there is technical debt, you do need to be aware of that and potentially build that into your designs. Do not mark your own homework, and do not rely on your customers to mark their own homework, particularly in regulated environments. As we see more regulation around financial services, healthcare, travel, there is a tendency for the regulators to ask the banks to self-certify everything is working. So they go back into their gateway logs, they pull the data from the gateway logs, they send in happy numbers, everybody loves. And then the first time they get into a dispute with a third party, both parties sit in front of the national regulator and say they're lying. And both have brought receipts to prove the other one is wrong. So there needs to be an independent view of API dependencies and the API supply chain. And that goes back to what Mark O'Neill was saying this morning. You have to understand the sort of continuum of what you are consuming and what impact it could have and how it could work. You must, and this is a huge problem in financial services and other areas, monitor with production accounts using real security. You wouldn't try and do any IT system in the world and pretend I tested it, I've deployed it, but because there's a hard internal risk and compliance problem, I'm not going to monitor production. It can't be done. Most of the banks in the UK have now won that one with their risk and compliance teams, but we're seeing other jurisdictions. The US is still far behind. But it's essential. You just can't hope for the best with IT systems and monitoring. And then be wary of existing tools. And we've seen this a lot where somebody's put a lot of investment into Dynatrace or into AppDynamics or New Relic, or they've got a very big SolarWinds setup, and they go in and they say, well, we'd like another budget for another tool. Yes, but you've got 3 monitoring tools, isn't that enough? It reminds me of a gag from a terrible British medical sitcom where the hospital administrator is looking at their drugs budget and goes, you've got all these placebos, they're very cheap, can't you use them instead of the drugs? Relying on other tooling that doesn't do APIs and isn't designed from the ground up for APIs and doesn't understand what they look like is just going to build up problems for later that you will have to deal with and find a way around it, particularly in the security space. So I'll end with a little plug. We provide end-to-end monitoring across all of the facets of API services, and then we provide insights as a independent assurance of how things are working. Typically, we pick up issues in the supply chain about 30 minutes before you'll find the suppliers have found out themselves. There is a tendency in our industry, my final point, which has been touched on by other speakers today, is there is a tendency towards DevOps by Twitter, that everybody relies on Twitter telling them something's gone wrong because the status page of the service hasn't changed yet. What we observe is it takes between 30 and 40 minutes for anyone to admit that they have a problem. And it can be a really nasty 30 or 40 minutes where you're trying to find which of your systems is down, and it turns out none of them are. So, thank you. Thank you for coming. And if you have any questions, please feel free.
Thanks very much, David. We have time for questions. If you have a question, please raise your hand and we'll get a microphone to you.
Hi there. You mentioned earlier about the sandboxes and them not being available, all the time. Have you picked up a trend where sandboxes are only spun up temporarily, just for testing purposes, and reserving resources just for a short period of time, rather than having it run permanently?
Yes. That was a good one. No, yes, I have. And we've seen that. We're also starting to see a lot of product managers fighting back against their own teams on that. Because if you're if I pick a large credit card company we work with, each of their integration partners needs to have access to a sandbox that works the way their integration works, so they understand everything is working, and they want to test every build in the sandbox. And what has historically happened is they'll build a sandbox and then ignore it for months. And then when somebody comes to test against it, it's not there or it's not responding properly. And yeah, it's a very frustrating thing, because if you look at the very successful API-first solutions, the Twilios and others, they have great sandbox solutions that work almost identically to their production environments, and they're there 24/7. And in something as complex, something where you do need to have quite serious permissions to access the production environment, you have to have a sandbox you can rely on. You can't just pretend that everything's going to be hunky-dory the day you go live.
Thanks.